So today we are going to solve a question that is, find the ceiling and floor of a target element or of a number in a sorted array. Okay, so let's see. So first of all, if the question says sorted array, then the first thing that strikes to our mind is binary search. Yes, binary search, this is an efficient way too. So let's go for binary search. Okay. So if you don't know about binary search, you can search it from the net, and you can also see its video. There are thousands of videos available for binary search on the YouTube itself. Okay, so in binary search, as we know, the search space is getting reduced to half. Okay, so first let's mention the indexes. Okay, so we have something called as start, then end, and then is mid. Now how to find the mid? Mid can be found out by mid is equal to mid of this range, that is start plus end. So sorry guys for this, I'm not experienced in this, so ignore it. Start plus end divide by 2, that is my mid. Okay, so here what would be my mid? That is 0 plus 6 divided by 2, that is 3. So this would be my mid element. Okay, oh, if we forget the target element, so let's say my target element is 9. Okay, my target element is 9. Okay, so this is my start, mid, end. Okay, ceiling, floor. What is ceiling, floor? Ceiling, the upper surface of a room where the fan is fixed, that is known as ceiling. And the floor is the lower surface on which we walk. Yeah, that is the simple definition of these terms. Okay, so the same thing is with the numbers. Ceiling is above us and floor is below us. Same thing is with the numbers too. So with the numbers, for example, if we have a number that is 9, that is my target element. Okay, that is my target element. For this, ceiling would be the number which is equal to or just greater than this element. Okay, and floor is the number which is equal to or just smaller than this number. In this question, my ceiling and floor would be, ceiling would be the number that is equal to or just greater than 9. So here in this, the number that is just greater than 9 is 10. Okay, so that would be my ceiling. Yeah, that would be my ceiling, that is 10. Okay, and what would be my floor? Floor is the number which is just smaller than or equal to 9, that is 8. That would be my answer. Okay, that would be my answer. First of all, let's apply binary search on this. You know the question now. Okay, so let's go towards the solution. Okay, so this is start, this is mid, this is end. Okay, so let's go ahead. So check whether the target element, that is my 9, whether the target element is greater than mid. Yeah, my target element, that is 9 is greater than mid, that is 8. Okay, if it is greater than mid, then my search space would be, start would be equal to mid plus 1, that would be my start, and new mid would be 4 plus 6, that is 10. 10 divided by 2 is 5, so this would be my mid. Okay, this would be my mid. Now I will check 13. If my target element is greater than 13, no, it is less than 13. Right, so that means my search space would be, now the element may lie in the LHS side, as my target element is smaller than this. So end is equal to mid minus 1. So mid minus 1, that is, this would be my end. Okay, for this also condition is start is less than or equal to end. So it is equal here, so the condition is true, the loop will run. Okay, so if my target element, that is 9, if my target element is less than, is it greater than 10? No, it is less than 10. If it is less than 10, then my search space would be mid minus 1. If this is mid minus 1, that would be, this would be my start. Sorry, this would be my end. End will change. Right? This is my start. So now my end is equal to 3 and my start is equal to 4. This condition gets violated. The loop will not run. And we got end is equal to 3 and start is equal to 4. Aren't these the ceiling and floor of that number? Okay. So you can understand this by, if you don't understand this here, for the true condition, the search space would look something like this. This is my start, this is my end, and my mid will lie somewhat over here. Right? If this condition gets false, right? If this condition gets false, see, if it gets true, if my target is equal to, that is 9 is equal to array of mid. Okay? If my target is equal to array of mid, in that case we have find the ceiling or floor, anything you can say, because in both the things we say ceiling is the number that is equal to, right, or greater than the number, and in floor we also say the number which is equal to or just less than the target element. Okay, so in that thing I found the element, I found the ceiling and floor, right? But in this case, if my condition gets violated, right, so here we can say my end is somewhere like this and start is somewhere like this. Okay, and if it is a sorted array, then ceiling would be here, because it is a number which is greater than my target element, and floor would be here before then ceiling, because it is a number smaller than the element. This is a number greater than the target element. So this is my floor. It is becoming something like this. This is my floor and this is my ceiling. Okay, there are some base cases, we have to, base cases or we can say edge cases, we have to search if the target element that is given, if it is itself the largest number. So how can we find the number which is greater than the target element? So for that case we have to apply some condition. And in the case for floor, if we are applying for the edge case, in that case it would itself be -1. We don't have to apply an extra condition for the things, right? If my floor is very less than, is the smallest element in the array, is less than the smallest element, for example my target is 1. If my target is 1 and we have to find a number which is equal to or less than the target element, so we can't find in this array, so it will itself return -1, because floor is indicated by start. Is it start now? Yeah, no, floor is indicated by end and this is indicated by start, and when the condition gets violated, end becomes further and gets ahead of the start. So end would be somewhat like here at -1, at -1. so it would itself return -1. So we don't have to apply an extra condition for that. Okay, got it? So let's do this code in Visual Studio Code, and I'm going to provide the GitHub link for the code. Okay, so let's start. So let's create a new file. I'm going to do the code in Java, so I'm creating a Java file. Okay, so let me have an array. Int array is equal to that my let's take the array that is 2 4 7 8 10 13 17. Okay, 2 4 7 8 10 13 17. Okay, is it visible to you guys? Okay, so let's create a function for the ceiling. Static int ceiling. Okay, it is going to return an integer that would be my index of the starting position. Sorry, not the starting position. Index of the ceiling of the number of the target element. Int array would be passed as a parameter and a target element would be there. Okay, we have to simply apply binary search for this. Binary search, we know the binary search code, while start is less than equal to end. But where is our start and end? We have to create it. Int start is the starting index and end is the ending index. Okay, array dot length -1, that would be my ending index. Okay, if my target element is less than the array of mid. Okay, now where is mid? We also have to create it. Int mid is equal to start plus end and closing them in the parenthesis divide by 2. Okay, that would be my mid. So if my target is smaller than the array of mid, so it would lie something over left hand side. Target is smaller, so for the left hand side end is equal to mid -1. Okay, else if my target is greater than array of mid, for that my element would lie somewhat over RHS, right? If it is in RHS, then start is going to be mid +1. Else only one case is left, that is target is equal to array of mid. If it is equal, then we have to just return that index. Okay, because as we know, what is ceiling? Ceiling is a number which is equal to or just greater than the target element. Okay, that would be my ceiling. Okay, and at the end, as we know that the ceiling is represented by start, so we have to return the start. Okay, and we discussed about that edge case. We have to apply an extra condition for it. If the target is itself the greatest element, not the greatest, it is even greater than the greatest element present in the array, in that case you have to return -1. Okay, so let's go for it. My code is all completed. Let's say my target is 9, as we understood in the example, and I'm going to calling this function ceiling here, array and target. Okay, let's run it. It is showing 4th index. What is present in 4th index? 0 1 2 3 4 10. So 10 is present in the 4th index. For this we have 4th index, that is 10. So 10 is my answer. Okay, 10 is my answer. For ceiling also, I am going to copy paste the code. Okay, let's make a file named as floor.java, and I'm going to copy paste this code. I'm going to change the name of this file to floor. Okay, the everything remains the same. Floor, this is floor, and in floor we don't need any base condition for it, right? And what is floor? Floor is a number which is equal to or just smaller than the target element, right? This is end, start, and the floor is represented by the end. Okay, let's run this. It is giving me 3. And now what is at the third index? 0, 1, 2, 3, that is 8. So that's the correct answer. Okay, that's the correct answer. That is, my third index is 8. So let's check it for the case if the target element is itself if it is itself the smaller than the smallest element present in the array. Okay, then it would by default return -1. We don't need to write an extra condition for it. It is returning -1 because it is represented, floor is represented by end, and if the condition is violated, it becomes something like this: end comma start. So end would be somewhere like here, and the indexes are starting from 0. This would be -1. So that's why it is giving the answer -1. Okay, and in the case of ceiling, let's say we take an element which is greater than the greatest element present in the array. Let's say we take 20. For 20, it will go to the condition we mentioned, that is this. Okay, it will return -1. But if we don't mention this condition, it will return, let's see what it returns. Guess the answers in the comment boxes. Okay, it is returning 7. Why it is returning 7? Because if the condition gets violated, it would be something like end, start, and ceiling is represented by start. Start would be somewhat like here. So this is 0, 1, 2, 3, 4, 5, 6. This would be 7. That's why it is returning me 7. Okay, so I know you must have guessed the answer. Okay, so that's why this condition is necessary. Okay guys, this is my first video on YouTube. I hope you guys like this video. Guys, subscribe and comment your queries below. I will be very happy to answer your queries. Okay, goodbye.